Hi all, here we're going to take a look at graphing sine function with rational amplitude. Let's say we are just looking at the basic y equals to sine of x. Period of this function will be 2 pi because it looks for how fast will this function complete a circle. X is not being multiplied by anything or divided, so the angles will be unaltered, and you need 2 pi or 360 degrees to complete a circle. You can only guarantee the sine to simplify into whole numbers if the calculations are performed at these benchmark angles, because anything in between is most likely going to give you a radical which has decimals and doesn't simplify into a nice whole number. The first angle I'm going to start simplifying will be sine of 0 radians or degrees. You can calculate these values in degrees if it helps you understand what's going on. So sine of 0 is 0. You can actually put these values into your calculator to follow along. The next angle I'm going to work with will be sine of pi over 2, which is 90 degrees, and sine of 90 is equal to 1. So the next special angle you want to calculate for sine will be here, 180 degrees or pi. So sine of pi gives you 0. The next angle that you want to do calculations with is on negative y-axis, which is 270 degrees or sine of 3 pi out of 2. And this is equal to negative 1. You can't stop here because the circle is incomplete, and the next value you want to calculate is here, sine of 2 pi or sine of 360 degrees, which is equal to 0 again. The coefficient in front of sine is the amplitude. So we have one sine, which means it will go up to 1 and it will go down to negative 1. The x value will be labeled with the angles. So we had first angle we used was 0 degrees, then we have pi out of 2, then we have pi, then we had 3 pi out of 2, and we had 2 pi as the end of our curve. Sine of 0 is 0. It will go to the coefficient, so sine of pi out of 2 is equal to 1. Then sine of pi is equal to 0. Sine of 3 pi out of 2 is negative 1. And sine of 2 pi is 0 again. So this is our basic sketch of a sine curve. There are two things you need to remember. You want to start at angle equals to 0. Then you want to take the period. You can split it into 4 pieces. That will give you the increments to add towards your starting angle. Our period was 2 pi. We divide it into 4 pieces, and this simplifies into pi out of 2. To get the x values algebraically, the first x value is always whatever makes the angle of the sine function 0. In this case it was 0. The next x value will be, you take the previous angle and you add a quarter of the period to it. In this case it's simplified into pi out of 2. So second x is pi out of 2. the next x value would be, you take the previous value, which was pi out of 2. You add a quarter of the period, so plus pi out of 2 again. We get 2 pi out of 2, which simplifies into pi. Then we get the next x value, which would be, we take the previous x, which is pi, plus pi out of 2. That was a quarter of the period. We need a common denominator, so denominator times 2, numerator times 2. And we get 3 pi out of 2. The last x value will be 3 pi out of 2 plus a quarter of the period, which is pi out of 2. And this gives us 4 pi divided by 2, which is 2 pi. Here we have to sketch one complete cycle of y equals to 2 out of 3 sine x. We need to determine the period, amplitude, and label the coordinates of the 5 points. Period is always 2 pi divided by coefficient of x. So in this case, we only have one x. That's 2 pi divided by 1, which gives us 2 pi back. Amplitude is just the distance from the center line to the highest point, and it's the absolute value of the coefficient of the sine function. So absolute value of 2 out of 3 is 2 out of 3. So we have x and y equals to 2 out of 3 sine of x. So the starting point is always whatever makes this angle 0. So if we just have x, the value that will make that angle 0 would be 0. Now y will be 2 out of 3 times sine of 0. Sine of 0 is 0, so this gives us 2 out of 3 times 0, which is 0. The first point is 0, 0. The next x value will be the previous x value, which was 0, and we want to add to it a quarter of the period, so 2 pi divided by 4. Quarter of the period equals 2 pi divided by 2. So we want to add pi out of 2 to 0. This will give us pi out of 2 as our next x value. So we get pi out of 2 here. So now we can calculate y. We get 2 out of 3 times sine of pi out of 2, and sine of 90 is equal to 1, so we get 2 out of 3 times 1, which is equal to 2 out of 3. So on our graph, 2/3 will be roughly here, 2 out of 3. So when x is pi out of 2, y is 2 out of 3. The next x value will be, we take previous point, which is pi out of 2. We add to it quarter of the period, which is pi out of 2. And this gives us 2 pi out of 2, which is equal to pi. Next value is pi. Now we can calculate y. Y is equal to 2 out of 3 times sine of pi, and this is equal to 2 out of 3 times sine of pi is 0, and the next value is 0. So here's our next point. When x is pi, y is 0. The next x value will be, I'm going to take the previous point and I'm going to pick this value before I simplified the fraction, which is 2 pi out of 2, because it has common denominator with the quarter of the period, which is pi out of 2. And we get 3 pi out of 2 for our x value. So here we got 3 pi divided by 2. Now we can calculate y. We have 2 out of 3 times sine of 3 pi out of 2, which is 2 out of 3 times sine of 3 pi out of 2 is equal to -1. This was equal to -2 out of 3. negative 2 out of 3 will be around here, negative 2 out of 3. So when x is 3 pi out of 2, y is negative 2 out of 3. And last but not least points, we get 3 pi out of 2, which was the previous x value. We add to it last quarter of the period, pi out of 2. This gives us 4 pi out of 2, and we get 2 pi. So last point is 2 pi. Now we can calculate sine. So we have 2 out of 3 times sine of 2 pi. But if you remember that 2 pi is coterminal with 0 pi angle, we're going to get 2 out of 3 times sine of 2 pi is 0. So this value is equal to 0. And here we go. Now we just connect our 5 points with a nice little curve. Here we have to sketch one complete cycle of y equals to negative 1/3 sine x. We need to determine the period, amplitude, and label the coordinates of 5 points. Period is always 2 pi divided by coefficient of x. So we have just one x, so 2 pi divided by 1 is still 2 pi. Amplitude is the distance from the center line to the highest point or the lowest point. Distance is always positive, and it will be absolute value of the coefficient of sine, which is negative 1 out of 3. Our amplitude is equal to 1/3. The x values will be the same as we had in previous problem. We want to start at angle equals to 0, so here we're going to start at 0. Quarter of the period will be 2 pi divided by 4, which is pi out of 2. 0 plus pi out of 2 gives us pi out of 2. Pi out of 2 plus pi out of 2, we get 2 pi out of 2, which is equal to pi. 2 pi out of 2 plus pi out of 2, again we get 3 pi out of 2. And 3 pi out of 2 plus pi out of 2, we get 4 pi out of 2, which is 2 pi. Now we need to calculate y. So y is equal to negative 1 out of 3 sine of x. So the first point will be negative 1 out of 3 times sine of 0, which is 0. Now then we're going to get negative 1 out of 3 times sine of pi out of 2, which would be negative 1/3 times 1. So we get negative 1 out of 3. The sine function starts at 0, then it goes to the coefficient, then it goes back to 0, the negative of the coefficient. So in this case, negative of negative 1/3, it would be positive 1/3, and it would go back to 0. If there are no shifts, this is the shortcut you can use. And you will have shifts in the graph if you see plus or minus in your function. So let's plot these points. We have first x is 0, then we have pi out of 2 pi, 3 pi out of 2, and 2 pi. So when x is 0, y is 0. When x is pi out of 2, y is negative 1/3. So here's our point. When x is pi, y is 0. When x is 3 pi out of 2, y is 1/3. So 1/3 is around here. And when x is 2 pi, we're going to go back to 0. And here's our sine curve. That's all.